1, 2, 3. Yes. Okay. By the way, first of all, I'd like to thank everyone for coming here and seeing my presentation. I'm here to share something really relevant today in our future and what's happening right now in the AI and software development. Thanks also Build Stuff for inviting me to speak here, coming from Oslo, Norway. So yes, and I have some a little bit of introduction also in my slides, so you would see where I came from. And yes, so yeah, we can start now. Okay, so everything's good. This mic, okay. I was like, thought I'd be using the other one. So, the rise of vector databases. Again, so Devlin Duldulao. I'm originally from Manila, Philippines. I've been living and working in Oslo, Norway for 4.5 years. I'm a Microsoft MVP working for Inmera. It's a consultancy. And during pandemic, I couldn't go home, so I decided to write some books. I started with my first book, which is ASP.NET Core with Vue.js, followed by Practical Enterprise React, which is I co-authored, and co-authored another one, Spring Boot and Angular. So much for that. Why I'm here? Just to give you information, you know. For example, just to warn you, in the world of AI and LLMs or large language model, if your company needs to tailor or it needs a custom model, for example, this one tailored for the specific domain or custom model, in short, it's quite expensive, you know, the pricing. I'm not sure if you can see it from the back. So you can see here, creating a custom model in OpenAI would cost start, and this is a form, by the way. You can verify the message here by going to this URL, and it says there $2 to $3 million. That's quite large, right? But that's not the main topic here. We can start with agenda first. So agenda would be what is a vector, what is an embedding and an embedding model, vector database, RAG, and then after that, I will do some demos so you'd see, we'd appreciate not just seeing the slides, hybrid systems and reranking, and then LLM applications architecture, and then we're gonna summarize it. Okay, so we can start with keyword search versus semantic search, right? So keyword search, this method retrieves documents that contain exact matches or close variations of the terms in the query. Whereas semantic search, this method retrieves documents that are conceptually similar to the query, even if they don't contain the exact terms. It relies on the semantic or the meaning, understanding of the content. Let me give you a quick demo of this so you would see. Okay, so a good example of keyword search. So I went to this online drugstore and I searched for eye pain. For example, I'm a user, I'm looking for a medication, and eye pain. Okay, so since it's a keyword search, it's going to search for a keyword pain and eye. So as you can see here, we have different pain. We have joint pain, which is, it's a pain, but it's not related to eye. Eye drops, it's not pain, but it has a keyword eye. Children's pain, sinusitis, sinus pain, etc. So you get the drift here, right? That if you search eye pain, you're gonna have these eye keyword, pain keyword, but it doesn't give you the medication related to eye. That it's random. But this can be improved by using a semantic a semantic search. So you're looking for a meaning or synonyms or related phrases. So I search also eye pain, and this is what I received from. This is not a real online drug store. This is just an example of one of the vector database vendor. So these are, seems like all these are medications or drugs. And if you read the details or the description, it's just there, conjunctivitis, which is, infection in the eye, dry eyes, here dry eyes, retinal problems. So not exact words, but retina, conjunctivitis, and dry eyes, they're all related to eyes, right? Vision also here. So this is an example of semantic search in action. So this is just an improvement of what you can do with searching, right? Sometimes users don't know exactly the keywords. The intention there is the users would describe what the user wants, describe it in the form, and then sending it using the web application. So let's go back to the slides. Okay. Oh, so that's just a quick demo. So now we have a little bit of understanding, like a quick understanding of keyword search and semantic search. Now let's talk about vector. What is a vector? So vector is just an array of numbers, right? In mathematics, a vector is a quantity that has both magnitude and direction. It looks simple. You can hard code this in your programming language of choice. It's easy. But what about embedding? So embedding is a specific type of vector representation where high-dimensional data is mapped to vectors of significantly lower dimensions. If this is hard to grasp, just think that it is an array of numbers with meanings. Embeddings, right? This is just an array of numbers with meanings. The idea is to capture the semantic meaning of the data in a dense vector form where similar items are placed closer together in a vector space. So the process is that, you need an embedding model. That's first, in order to generate an embedding. This can be open source or paid. The open source, for example, would be sentence transformers. Is good enough for just, creating embeddings for an English text. If you're using English language, sentence transformer from Hugging Face, that's enough. It's free. Or if you want something more, you can use text embedding, ADA, 002 model from OpenAI, and more use cases. For example, you also want to generate embeddings in different languages, not just English. Or you have unstructured data like images, audio, video. That's when it might use a closed source or paid source. So as you can see here, these are unstructured data. Then send it to embedding model to process it and generate embeddings from it. Now we have embeddings. We need a system where we can store embeddings, right? And the data that the embeddings represents. So you're actually not converting the image. For example, the image, you just need to create an embeddings for it. The numbers, it's like an address, right? Okay, let's start with relational database. This is built to store structured data in columns and rows. We are not going to use this for saving the embeddings, right? Neither a NoSQL database. Document database is a NoSQL database that is focused on storing, retrieving, and managing document-oriented information. What we need is this, a vector database. It's specialized database, where you can store many vectors alongside its structured or unstructured data, and then retrieve them when needed. When I say alongside, you'll be saving both of the embeddings and the data that it represents. So two things you're saving in vector database: the embeddings again, and for example, the paragraph that you're trying to save, right? Both of them. And here's a better way of looking at this. So while storing the vector embeddings, the embeddings will be grouped depending on how closely the words are related. For example, you're querying or you're able to save things about laptop or MacBook, right? And then you query the word desktop. The desktop query might give you results related to MacBook or laptop, since they group together. That's one. The vector database knows how to group them, right? And you have here thyme, rosemary, oregano. These are herbs, totally different, right? And of course, they're related in this area, or could be in different area, because they're totally the opposite or different from gadgets. So imagine embeddings like GPS. Embeddings are like latitude and longitude coordinates, but the array have hundreds of elements inside of it. What about vector indexing? So it involves organizing and structuring high-dimensional data, the vectors, to facilitate efficient querying. It's about how the data is stored and accessed. And this is very important, by the way. Not so much for example, in SQL and NoSQL. Here in vector database, you need to know some algorithms, because this is about performance tuning, or how to make your database performant. I'm going to tell you later more about that. So for example, of vector indexing. So again, indexing is storage. Saving the embeddings, right? You have here KD trees, ball trees, tree base, hashing, clustering. You have base index, proximity graph, base indexing, compression. These are all vector indexing. So we have this vector indexing saving our embeddings. Now, we also have search algorithms for searching. So these are techniques to retrieve the most relevant vectors from the database in response to a query. It's about how the data is queried and retrieved. And we have here k-nearest, KNN, k-nearest neighbors, or approximate nearest neighbor, or ANN. So KNN is used when the data set is manageable or few, and the accuracy of the result is very important, while ANN is preferred when the data set is large, like millions. So in ANN, the application can tolerate degree of approximation for speed and scalability. So think about it. There's a trade-off in here. KNN data set is small, so KNN will iterate in all the embeddings and compare it one by one. Imagine you're gonna be doing comparing of millions of data in KNN. Now, there's gonna be latency. It's gonna be slow because the performance there is gonna be linear. The more data you add in a vector database that is using KNN the more it will be slower, right? So a workaround in that is using this approximate nearest neighbor. So the trade-off of using this is you're gonna have just an approximate results, not the nearest accurate that you can get from the database. Why? It's not gonna do a lot of this iteration for millions. It's just going to trade the accuracy with the performance gain. So again, this is for small database. This is going to be for large because it's going to trade, the accuracy versus the performance. You need more performance in millions of data. That's why you're going to be using ANN. So that's why. There's another one terminology that it's good to know in vector database. It's called distance metrics. So let's talk about this. Distance metrics are used to determine the similarity or dissimilarity between data points, which are the vectors, right? And here are the standard distance metrics. So now imagine you use the ANN or the KNN. Now you have this data that you gathered, right? This metrics here right now is about creating points or ranking the data that you gathered. And what it's going to do, let's say this is your query. This is your query. Now you're gonna this metric will try to look how relevant this thing here, this query, with this embedding that you already stored. So this is just one of the metrics. Euclidean distance is this one. This is an ordinary straight line distance between 2 points in Euclidean space. For vectors, it's the square root of the sum of the squared differences between corresponding elements here. This is good for image similarity. Another one, there are just a few, but we're gonna do 3 only, but there's more. Another one that's very popular is cosine similarity. So measures the cosine, the angle between 2 vectors. So it determines whether 2 vectors are pointing in roughly the same direction. This is good for text, concepts when you're creating embeddings. And another one, dot product, also known as a scalar product, measures the product of the magnitudes of the 2 vectors and the cosine of the angle between them. So in algebra, it is the sum of products of corresponding entries of the 2 sequences of numbers. So this is good for both for image and image similarity and text. So you will see them in action later in the demo of vector database. So now we know how to check, this rank, this how similar 2 points are between, for example, your query and the stored embeddings. Let's see who are the vector database vendors out there. We have Pinecone. So Pinecone excels at simplicity and user-friendliness, providing a cloud-native and managed service that abstracts away the complexities of vectorization and indexing. That's one. We also have Weaviate. Weaviate is engineered for an excellent developer experience, and performance, supporting fast sub-millisecond search results and both keywords and vector-based search functionality. When I say vector search, it's kind of similar with semantic. It's just, you're querying embeddings. That's why it's called vector search. But in the end, it's a semantic search. We also have Quadrant or Qdrant. So it's built in Rust. Qdrant promises efficient resource utilization and is emerging as a first choice vector search backend with rapid community growth and strong focus on search accuracy and scalability. Another one here will be Milvus, Zilis. Milvus is highly mature and scalable database, offering a comprehensive set of algorithms and unique advantage of this, ANN, the algorithm that you see earlier, implementation for efficient on-disk vector indexing. And then Zilis, so Milvus is the open source. Zilis is company behind a closed source alternative for Milvus. Zilis is commercial parent, in short, entity of Milvus, and offers a fully managed cloud solution built on top of Milvus. What about Chroma? Chroma enables rapid prototyping with its Python JavaScript interface and embedded architecture, offering an array of hosting options and unique features like quantifying query relevance. We also have LansDB. So LansDB innovates with a serverless architecture and a novel columnar data format, simplifying infrastructure complexity and facilitating semantic search applications directly linked to data lakes. We also have Vespa. Vespa stands as an enterprise-ready solution, offering mature and optimized hybrid search capabilities through a combination of keyword and custom vector search functionalities. We also have VALD, specializes in handling multimodal data through a highly distributed architecture with a unique focus on fast ANN search algorithms. We also have this Elasticsearch with vector database built in, Redis also, and Postgre. These databases offer the advantage of integrating vector search functionalities into existing data stores, providing smooth transition into semantic search capabilities for current users. So I would recommend trying all of them before deciding which one to choose, because each one of them has different DX or developer experience, in my opinion. So I cannot recommend one. You just have to try, because you might find, oh, this is something it's hard to use, and then you find out the other one, oh, this is really easy to use, right? So that's the idea there. Now we are done with explaining what is a vector database. Let's see how it can help AI applications. But before that, just some basic things here, like what an LLM is. So LLM stands for large language models, are machine models trained to predict the next word of a sentence. It would appear that the application talks to you like a human, like in ChatGPT, right? Because the output is grammatically correct, related to the input, reasoning, etc. So GPT or LLM, those weren't trained to memorize the data, the whole internet. It was just trained to predict the next, text in the sentence, in an incomplete sentence. That's sometimes that's why, for example, in Copilot, GitHub Copilot, LLM was also trained to not memorize the whole code. Or, for example, if you're coding and it's going to memorize. No, it was trained to predict the next, code or next syntax to make it correct, not, just by memorizing the text. That's how it works. That's how LLM were trained. But why vector database is hot right now? So look at the image here. It is a diagram of the evolution of LLMs. We are in a period now where businesses are bringing generative AI into their applications, right? But there's a problem. The LLMs, they have shortcomings. LLMs, it could be better. You have this limited to the information used to train the AI information until April 2023, but this is using the latest GPT Turbo that OpenAI released last week. If you're monitoring what's happening in OpenAI, they released this latest model, which is GPT-4 Turbo. It has the latest knowledge of the whole public internet up to April 2023. Before that, it's only until September of 2021. So anything, for example, if you're using a tool in your development, for example, Quick, a front-end framework, or Bun, now it's good time to search in GPT and ask GPT, because before October 2021, there's not much documentation of, for example, Bun, the latest runtime in JavaScript, right? But before April, there's like some documentation, for example, other frameworks. Now you can talk to GPT and ask, you can ask anything, and as long as you know that there was already documentation before May of this year, and if you're using the paid version of ChatGPT. So you can get this GPT for Turbo. But anyways, I'm not here to sell OpenAI paid services. Just letting you know what do they have. So solutions in the shortcomings of LLMs, custom model for your company. The expensive one that I showed in my first slide. It is any model that has been tailored to meet specific requirements. Second one is fine-tuning. It's a process in machine learning when you start with a pre-trained model. Pre-trained model meaning it's already there, pre-trained. It's already been trained. You're not gonna train a model because it's very expensive, by the way. There's no such thing. I mean, there's such thing as training your own model, but you're not gonna do that because it's really expensive. So most of the time, you'll be using a pre-trained model already. So for example, here in fine-tuning, it's already pre-trained, and then you just continue the training process with a new data set that is typically smaller and more domain-specific, but you need someone who knows what they're doing, for example, data scientists. But here's the RAG. This is actually what we're going to do here. Retrieval, augmented, generation, and this is related to vector database. That's why we discussed the vector database before this. And it looks like this, the diagram. So RAG is just a design pattern, by the way. So from the user, you convert your prompt into embeddings, right? Or generate, sorry, not convert, generate. The prompt, the text, for example, who is Michael Jackson, something like that. That's a prompt, right? And that prompt you need an embedding as an equivalent embedding for that who is Michael Jackson. So, sorry, just taking picture. And then the prompt will return, right, the embeddings for you. So that's why you have here. It will return the embedding, select the vector. And that vector, you will use that to check in the vector DB. There's existing vectors already here. Guys, there's existing vectors already here. You're just sending these embeddings to, again, to do a similarity search, similarity check, whether there's a similar embeddings in the vector database, right? And then the vector DB will return you the data that you need in here. And then now you need to combine your prompt, who is Michael Jackson, with the data from the vector DB, right? Again, this will solve the problem with hallucination. Because sometimes LLM will answer you like stupid answers. It's just, again, it doesn't know what happened in reality. It's just predicting, making the sentence correct, predicting the next text. So now you have this, the prompt and the data. You need to combine it. That's why you have this prompt template. This is called prompt template because you're combining the data from the database and the original prompt, who is Michael Jackson. Now you're going to send that to OpenAI or Azure OpenAI or any other LLMs provider so that you can get the correct answer. And going to show it to you right now, actually. So we just need to, again, do mirroring here. Mirror, mirror, mirror. Mm-hmm. Okay, fine. Why do I have to go here? Jeez. Okay, okay. Okay, so the demo here will be, I split it into two, by the way, a demo of vector database and a demo of RAG. So because I'm thinking if I combine this together, it will be just a lot to take. So I split it into two. Now we can go first to a sample of vector database. So I'm using here Python. You can use whatever you want, JavaScript or .NET or Java. There's like counterpart of this using an orchestrator or a framework. So installing sentence transformers, which is an embedding model. It's free. Qdrant, I'm using Qdrant here, another vendor of, another vector database vendor. And basically, okay, we're just importing now Qdrant client and sentence transformer. And now, as you can see here, I think I can do this. We have here encoder from sentence transformer and model name or path. This is something that you would choose, and it looks like this. This is pre-trained models of sentence transformer. Just going to, so you can see it here. There's some reference. Most of the time, of course, that's why documentation, reading documentation is very important. Here. So let's go back. This is just part of the sentence transformer here. I'm going to, yep. This is enough. The back, you can see it. Okay, good. So now we have the encoder using sentence transformer. Now let's feed some data into the vector database. So this is unstructured data. You can see this an array of objects. So imagine this is latest things that happen. Or for example here, these are books, right? Imagine the GPT wasn't trained with this kind of data. This is our own data, our own book. Okay, there's a lot here, right? And I'm using Qdrant client. It's located in my Docker machine. We need to have a collection name, which is, for example, here, my books. This is a name of my collection. There could be more. And with this one, so now we're going to create a collection name, vector params, encoder. This is from sentence transformer again. And the distance metrics that I discussed earlier, as you can see here, you can choose whether models, distance, this cosine or Euclidean or dot product, right? But some are default to dot product, some are default to cosine. So even if the database has some default, you still have to, to choose your own. So after creating the collection here, we're going to save the data, right? So here, as you can see, upload records. We need to tie it to the name of the collection, and the records will be the doc here. This is the data, right? This is the data, the doc, but we are creating embeddings on this data. That's why we have this encoder, encode. Encode is now we are going to generate embeddings or vectors for this documentation, this data, which is, again, this one, doc, right? Documents, as you can see here. And here, that's why you're doing this enumerate, and doc will be not converted, but the Qdrant here will, or the encoder here will generate embeddings, and Qdrant will upload it or save it in its database. So that's it. Now let's try this. Now I have here query movies about meals. About meals, a movie or a book about meals. So also here, we need to, again, this is prompt. Query is just a prompt. We need to encode it. We need to create embeddings for it, right? To do the similarity again, that's already been stored in the vector database. That's why we're doing this encode, encoder. And we can set limit here, like how many or the top, because it can supply you hundreds of results, but you need to only get, for example, 20 results or 10 or 5. Here in this example, I'm only getting 5 results. I'm only interested in 5 results. That's why I have the limit here. Query vector, correct. That's the encoder encoding the query. And now here, for loop. Now I'm just printing it or console logging it, right, with a score. And as you can see here, these are the scores here. So I'm just showing you. This is the score made by the distance metrics. This 0.45. The perfect score here is not perfect score. The ideal score here is near 1. So it's gonna be should be 0.99, 0.80, 0.7. This is quite low, but meals may be quite low because meals, chocolate, they're both food in that sense, right? The other one, the second one, 0.40 for 0. So meals, food, related, right? Meals and food, because meals are food. There's a word "it" here. So this is semantic, or this is a food chain. Second result. So this is how you would do this semantic search, because the vector database is returning you things that are relevant with your query. That's one. This is about vector database, right? What about the RAG? How are you going to use this in real world, in AI applications? So, RAG. Let's try a query to ChatGPT without RAG first. Anyone here is a fan of UFC, MMA? That's an example I use here. Anyways, not using RAG, the model is not aware of the date today. It still thinks that the present time is the date of its training. So gonna do some pip install. We have here OpenAI key. So my prompt is, when is the 294 UFC going to happen? It answered me back, this one. So again, the model is not aware of the date today. It still thinks the present time is the date because this happened last month. As of October, this is the response that I received. As of October 2020, there's no event schedule. It's already 2023 November, and it says here as October 2020. There's no event scheduled for UFC 294. The next scheduled event is 254, which is set to take place in October. It's out of date. This is from ChatGPT, by the way. It's out of date. Not using RAG. Another one. The example below will demonstrate that the model is hallucinating or responding an event that did not happen. I asked him again why the main card of 294 UFC, the main fight, was canceled. By the way, this is why it was canceled. So the main player here, some bruise or accident happened to him during a training that lacerated his eyebrow. So this is just showing that it didn't happen because of some accident happened of the player. Okay, so again, no RAG. The main card of 294 was canceled due to a positive COVID-19 test. That's that's funny, right? Because it's hallucinating. It's telling me things that I shouldn't know. Didn't happen. From one of the fighters on the card, health and safety protocols were followed, and the event was canceled out of abundance. So it's telling me things that didn't happen. Using RAG with data and prompt templates. So the sample below improves the quality of the response. So, for example, how many minutes I have left? Sorry. 4. Okay, so another example here. This is the query, why the main card of 294 UFC was canceled. And for example, this data came from vector database. Charles Oliveira suffered a nasty laceration. For example, you have this internal documentation, like, and then you constantly, like every night, you update the vector database with this. So it's updated. And Charles Oliveira, so this is what came from the vector database. So as you can see, I'm using now a prompt template, and this is how it looks like. Act as a search copilot, be helpful and informative. Now, it's different now. Based on the user's query below, which is this one, user input, which is this one, Y domain card. Here is some information about the query. It has the following information. Now I'm putting here, this is a placeholder. Now I'm passing here the data that I got from the vector database here. And then I have a note here, be concise. And then the result would be totally different, which is correct one. It appears that the main card of UFC 94 was canceled because Charles Oliveira suffered a laceration in his face, which forced him out of the fight. So that's the difference between no data, not doing RAG and doing RAG. And there's another different way of using this. Using RAG without data. What if there's no data in the RAG, in the vector database? You can tell the LLM, be concise and don't add any other details if you don't know about it, right? No information found, says coming from vector database. And you're just telling the LLM, don't say anything, don't make up things, right? If you don't know the answer, just shut up, something like that. And the result would be, I'm sorry, because there's no data here. I'm sorry, I'm not able to provide any information about the main card of the 294 UFC fight being canceled. However, you may be able to find more information about searching through news articles, blah, blah, blah. So at least it didn't answer me things that didn't happen, right? Even though there's no data in the vector database. This is prompt engineering, by the way. Create a template. You tell the GPT what to do. Be concise, and yeah, the templating. This is all about prompt engineering. You're telling the GPT what to do. So, time left already? 3 minutes or two. So, yeah, that's basically that's it. That's vector database and how you would use it in a real world application. Let's go jump back to really quick. There's also an improvement of RAG. It's called hybrid RAG. So as you can see here, we have the keyword search. We're now combining keyword and semantic search before sending it to LLM. This is called hybrid RAG. We're not disregarding keyword search because sometimes you need exact match like email addresses, measurements, right? Port numbers, and things about medical, legal, technical terminologies without synonyms. You still need keyword search in regards to those searches. That's why we have that. And lastly, hybrid RAG with plus reranking. You have keyword search and vector search. Now you have another model that would compare, collect these two results, and then do reranking. That's why it's called reranking. It's just another model there, cross-encoder model, which analyze which one is really correct. So that's why it's called reranking. It's like a second ranking, scoring of results from vector and keyword search, and making sure that you have the best prompt template or prompt for the LLM before you send it to the LLM. Prompt with data from results from reranking. So, and here's a table, evaluation, approved customer data, sets of Microsoft using relevant industry. This is just a benchmark of how hybrid plus semantic ranker is really like an improved versions of everything. So, yeah, maybe thank you for again, that's all. I don't have much time. Repository is here. If you want to check out the repo that I sample to you. That's it. And yes. Do you want resources also? Almost done. Resources is here. These are good resources, by the way, if you want to get started with a vector database and LLM. And I hope this presentation will help you get started with vector databases so you can start building AI applications that bring value to your users. Until next time, guys, peace out. Thank you very much.